Have you ever found yourself, wrestling with different AI tools, maybe using one LLM for writing, another for data stuff,
Oh, absolutely.
and all your important business logic or your special data is just stuck in your own systems? The
Yeah.
big question is always, how do you get these things to talk to your stuff and each other without building tons of custom connectors? It's a real challenge now.
It really is. I mean, we're in this exciting space, but it's also super fragmented, data, functionality, it's all sort of siloed off.
Right.
And bridging those gaps efficiently without, duplicating effort constantly or building crazy workarounds, that's a major hurdle if you want to use AI properly.
And that's exactly what we're digging into today. We're going to explore something called the Model Context Protocol, MCP for short.
Hmm.
And our guide for this is Zach Silvera's new book, Creating MCP Servers with OAuth. It's actually still being written, but it's already packed with really practical stuff.
Yeah, and our mission here really is to give you a kind of shortcut to help you understand what these MCP servers are, why they're becoming, well, pretty essential for AI integration down the line,
Okay.
and also the steps to actually start building one yourself, which are surprisingly practical. We'll even touch on sharing them and keeping them secure.
So if you want to get up to speed quickly on the cutting edge of AI interoperability, stick with us. Let's unpack MCP.
Let's do it.
Okay, so first things first, let's talk about the fundamental why.
Yeah.
Why MCP servers? The book really gets to the core problem, right? This need to share your specific data or functions across lots of different AI providers.
Exactly. You might like Claude for one thing, ChatGPT for another.
Right.
And without something like MCP, getting your unique stuff, your custom prompts into each one separately is just constant manual work. It's tedious.
So how does MCP fix that?
Well, what's really powerful is how it tackles that fragmentation head on. It lets you basically expose your existing system's data, even your current REST APIs,
Hmm.
directly to the AI models. So your internal info, maybe it's customer data, maybe it's your product catalog, your company knowledge base, it can just flow right into the AI interactions. No more copy pasting. It's a big step up.
And the book uses this analogy I really liked. It calls MCP REST, but for LLMs. What's so good about that comparison? How does that help us get it?
It's a great analogy because REST became the standard for web services, right? For
Hmm.
systems talking to each other online.
Yeah.
MCP is aiming to be that standard layer for large language models. So if you're building anything you want an LLM to interact with, fetching dynamic info, triggering actions, the book basically says an MCP server is probably how you'll do it going forward.
Okay, so it's like the way to connect things to LLMs.
Pretty much becoming that, yeah. And it's not just about connecting, it's about having a standard protocol level way to handle things like access control, even billing.
Ah, the money side.
Right.
Yeah.
Instead of building custom API keys and subscription checks for every single AI tool you integrate
That
with,
sounds like a nightmare.
it is. With MCP, you can define your access rules once, right there on your MCP server. And any MCP client, any LLM tool that supports it will automatically respect those rules. It makes monetizing your unique AI features or data way, way simpler and more secure.
Okay, that really clarifies the business angle. It's not just tech integration. So the why is compelling. Now, if you're listening and thinking, okay, I want to try this, the book makes it sound pretty doable, assuming you've got some basics down. What are those prerequisites?
Yeah, the author's pretty upfront about it. You need a solid handle on TypeScript. You need to be comfortable with REST APIs and, just general programming skills.
Got it.
With that baseline, though, the setup itself is actually quite streamlined.
And the book points to two specific tools to get going fast. First up, VS Code. Why that editor?
VS Code gets the spotlight because it has official support for the whole MCP protocol.
Ah, built in.
Exactly. So you can write your code, implement the MCP stuff, and test it all in one window. Connect right to your server from the editor. It cuts down massively on switching between different apps and tools.
Yeah, that sounds way smoother for development.
Definitely a productivity booster.
Okay, and the other tool mentioned is bun.esh. The book seems really keen on bun. Why bun instead of, say, Node.js, which is maybe more common?
Bun gets the nod mainly because it's faster than Node, significantly so, and it needs less configuration fuss.
Okay.
When you're learning something new, like MCP, the last thing you want is to get stuck wrestling with your environment setup right.
True.
Bun makes TypeScript just dot work out of the box. So you can focus on MCP, not build tools. Installation's super simple too, like a one-liner curl command on Mac or Linux. Then Bun init makes a new project, open it in VS Code, and you're basically ready to go.
And for a business leader listening, that faster setup means what? Faster prototyping.
Exactly. Faster prototyping, quicker iterations, less developer time wasted on just setup, gets your AI features out faster.
Okay, environment setup. Bun and VS Code humming along. The book then moves into actually building an MCP server. It starts with this idea of an STDIO server. What's that? How does it work with VS Code?
Right, so an STDIO server is designed to be run by the MCP client, like VS Code or maybe the Claude desktop app, locally on your machine.
Okay, so it runs on my computer.
Yeah, the client starts your server code, and then they talk to each other using something called the JSON RPC protocol.
JSON to RPC.
Think of it as just a standard, efficient way for two programs on the same machine to communicate. Like, one program asks the other to run a function, maybe addition, passes some numbers, and gets the result back in a structured way. It's good for local communication.
So it's structured talking over the command line, basically.
Really good.
Okay. And then the book jumps right into something that sounds really cool.
Right.
Custom prompts.
Oh, yeah, this is where it gets powerful. The book shows you how to make prompts that take variables, inputs, and critically, it uses Zod for validation.
Zod for validation. Why is that important?
Zod helps make sure the data the LLM tries to feed into your prompt fits the exact format you expect. It's like a guardrail. You define the structure, say, I need a string here, a number there, and Zod enforces it, prevents errors from weird AI outputs.
Ah, okay. That makes sense. Can you give some examples from the book? What kind of dynamic prompts are we talking about?
The examples are great. There's a one-shot task prompt that tries to write and commit code based on a task description.
Whoa.
Or one that takes a long message and rewrites it into short, punchy tweets. A more advanced one takes a GitHub issue number, goes and fetches the issue details, works on the code, commits it, and even creates the pull request, all from one prompt.
That's seriously impressive. So the value is you build these smart prompts once, and then you can use them in any AI tool that understands MCP without setting them up individually everywhere.
Exactly that. And the dynamic part is huge. Like, imagine a prompt that fetches livestock prices or reads data from a sensor and uses that in its response. It's way beyond just static text.
Okay, but if it's running locally with STDIO, how do you share these cool prompts with your team? That seems tricky.
Yeah, that sounds like a problem, right? An on-device server. How do you share? But the book has this really ingenious solution for teams.
Okay, I'm intrigued. How do you share prompts from an on-device server?
It's actually surprisingly simple and clever. Since Bun restarts automatically when code changes,
Right.
the author suggests just adding a tiny bit of code inside your server using setinterval to periodically run git pull.
We just run git pull every minute or so?
Yeah, something like await git pull.txt every 60 seconds. So if one dev pushes a new prompt or changes code to your shared Git repo, everyone else's local server running git pull will grab those changes. Bun sees the code change, reloads the server, and boom, within minutes, everyone has the latest prompts. No need for a shared server deployment just for internal team dev, just Git.
That is genuinely a brilliant little hack using tools you already have. Okay, so beyond dynamic prompts, what other MCP features does the book cover?
The next big one is resources. Now, you might think of static files like images in a chat.
Yeah, like uploading a file.
Right. But the book shows a really neat dynamic use case. Imagine you need the AI to see what a web page looks like right now.
Like a live screenshot.
Exactly. MCP resources let you generate that dynamically.
How does that work?
You'd set up the resource, use a browser automation tool like Puppeteer behind the scenes to actually take the screenshot of a live site and then return the image data, usually base64 encoded.
Okay.
And even cooler, you can use something called resource template. This lets you use path variables, like you can define screenshots.zack.code's path. Then, if the AI requests screenshots.zack.code's contact, your code dynamically screenshots just the contact page of that site.
Wow. Okay, that's very flexible.
Super flexible. The book does mention one little quirk they found. Nested paths, like test, don't seem to work right now for resources.
Right.
They've opened an issue, so it's something being worked on in the protocol.
Good to know. Any other features mentioned?
Yeah, it briefly touches on features that are coming soon in the book, like tools, which sounds like it could let your MCP server use other APIs, like a standard REST API and something called sampling. So more capabilities are on the horizon.
Okay, so we've got STDIO servers for local dev, even that clever Git pull sharing trick.
Yeah.
But what if you need this accessible more broadly? Over the internet or just on your company network? That feels like a bigger step.
It is a bigger step, yeah. And that's where HTTP streaming comes in. This is how you turn your local MCP server into a remote MCP.
Remote MCP. Okay. How does that work?
The book walks through using Express, a super common web framework for Node and Bun. You'd install it, Bun at Express, it types Express, then set up a basic HTTP server that listens specifically on a route, typically MCP, so maybe localhost 3000 MLCP.
So you're basically wrapping your MCP logic inside a standard web server.
Pretty much, yeah, making it accessible over the network. And the book suggests a particular way to structure it, a stateless design.
Stateless, what does that mean here and why?
It means each time a request hits that MCP endpoint, the server basically creates a fresh instance of your MCP logic just for that request. It doesn't try to remember anything from previous requests from the same user.
Ah, okay. Why do that?
It simplifies things a lot, avoids needing complex session management, tracking who's connected. It's similar to using things like JWTs for WebAuth instead of old-school database sessions. Keeps each request isolated, makes it easier to scale.
Gotcha. Simple and scalable.
And once that remote server is running, you can just add its URL, like http.yourserver.3000 into an MCP client, like VS Code, and use it from anywhere that can reach it.
Wow, okay. We've covered a ton of ground here. We started with that core YMCP as this REST for LLMs, solving the integration headache.
Yeah, standardizing how AI talks to our systems.
Then we looked at getting set up using VS Code and Bun for that smooth dev experience.
Right. Minimizing the setup friction.
And then building the actual server. The dynamic prompts were really the star there, being able to fetch live data, run multi-step tasks.
Absolutely. And that git pull trick for sharing them easily within a team using STDIO.
Can't forget that one. And we also touched on dynamic resources like the live website screenshots. And finally, leveling up to HTTP streaming for remote access.
Turning it into a proper network service.
So looking ahead now, the book mentions coming soon sections, particularly about OAuth integration. What does that signal for the future? Where is this heading?
That's a really important point. As these MCP servers become more common, how do we handle security? How do we handle payment?
Right.
The OAuth part mentioned in the book points directly at that. Things like enabling optional logins for your server. And crucially, checking if a user actually has paid or has an active subscription before letting them use a specific tool or resource provided by your server.
Ah, so proper authentication and monetization built in.
Exactly. It also hints at needing platform-specific tweaks, like maybe needing a special Claude IO scope for Claude integration, or specific server-send events, SSE, requirements. It shows that while the core MCP idea is powerful, making it work securely and commercially across different platforms will involve these kinds of authentication layers and platform details. That's critical for real-world adoption.
So the MCP journey is definitely still unfolding. This has been a fantastic way to get a handle on where it is now and where it seems to be going.
It's an exciting space to watch.
Absolutely. And if you, our listener, want to dive deeper and get the full hands-on instructions, we definitely recommend checking out Zach Silvera's book, Creating MCP Servers with Oath. It's available on LeanPub. It's clearly a great resource for exploring this really dynamic area of AI integration further.